Hi, this is a video on limiting reactants. So we are in module 10 and this is lesson 3. So we know all this. So when we have a reaction, is when we have more than one reactant, one of those reactants is going to kind of run out, and that then stops the reaction from happening anymore. And we call that the limiting reactant. And then if there is another reactant or reactants, the ones that are not going to run out, but still the reaction stopped, so they're going to have leftovers of those reactants, and they're called excess reactants. So kind of silly analogy, and you can see, so this would be kind of like a chemical reaction where the patty, whatever it is, plus the buns, plus the cheese, plus the tomato is going to give you the sandwich or the burger or whatever it is. So you can see that the limiting reactant here is the patties, because we're going to run out of them, and then that makes the reaction stop. We have to stop making burgers because we can only make 3 and then we're done. So you can see that. So we used up 3 of the buns, 3 of the cheeses, and 3 of the tomatoes. So the rest of, there's going to be leftovers of the bun, of the cheese, and of the tomato. And this is something like in life we encounter quite a bit. Also, if you make s'mores at home, graham cracker plus marshmallow plus chocolate gives you the s'more. And the limiting reactant, at least for my house, is usually the chocolate. So the chocolate runs out, then we're done. We usually have tons of leftover crackers and marshmallows. So this is now looking at it in terms of a reaction. So if here we have nitrogen and hydrogen reacting to form ammonia. So they were able to form 2 of these molecules, and then there was leftover nitrogen. So these are the steps that we use when we're doing these kind of problems to determine the limiting reactant. The reason we do this is because you have to know which one's the limiting reactant, and that's the one then that determines how much of all of the products are formed, how much of the other reactant is used. So these are the kind of steps that you're going to want to follow. So first thing we do is, if they're not already the reactants, so you'll always have 2 amounts of reactants now. If they're not in moles, you want to convert to mole. Then you want to pick one of the reactants and convert it to moles of the other. And then you have to ask yourself, do I have enough? If you have enough, yes, then the other reactant is the LR. And if you don't have enough, then that reactant is the LR. I know that doesn't make sense. Let me just show you. So here we go. So this is the reaction. So sulfur, it's S8 plus chlorine makes disulfur dichlorine. And in this question, our 2 reactants, we have 115 grams of S8 and 1.200 moles of chlorine. So first step is we're going to convert this into moles. So I previously did the molar mass just to save time. So I'm going to calculate it with you. So we get 0.4507 moles of S8. Second step then is to take the moles of the S8 and convert it into moles of chlorine, or vice versa. I'm going to take my moles of S8 and I'm going to convert it into moles of the other reactant, which is chlorine. So there's my coefficient. So it's 4 moles of chlorine for every 1 mole of S8. I'm getting that 1 up here and the 4 up here. So I'm going to calculate that. And when I do, I get 1.803 moles of chlorine. So I have to ask myself, do I have this much? And the answer is no, because I only have 1.22 moles of chlorine. So that means I am going to run out of chlorine first. So if I don't have enough of the one that I converted to, then that one is my limiting reactant. If I had gone the other way, and you don't need to do both, but I'll just show you, by chance, you will go the other way sometimes. So this time I would go, 1 mole of S8 for every 4 moles of chlorine. So when I do this, I get 0.305 moles of S8. And then I would ask myself, do I have this? Do I have 0.305 moles of S8? And my answer is yes, I have plenty. So because I have plenty, that means when I say yes, that means the one that I converted to is my excess reactant, and the one that I converted from is the one I'm going to run out of. This is my limiting reactant. So if I say no, then the one I converted to is my limiting. So either way, the chlorine is the limiting reactant here. So let me show you another one. So in this one, we have a reaction again with 2 reactants. So in the previous question, we figured out, if we look at our reaction, that this was our limiting reactant, and therefore the S8 is going to be my excess reactant. So we're going to do a similar problem here with a different reaction and different amounts of reactants. So here we have 880.2 grams of carbon dioxide and 41.6 moles of lithium hydroxide. So again, the first step, if they're not in mole, is to convert them to mole. So I'm going to take my grams of CO2 and convert to moles of CO2. And when I do that, I get 20 moles of CO2. Let me double check that. Yep. So that was step 1, convert them to moles. Step 2 is I'm going to convert one of the reactant moles to the other reactant in moles. So I'm going to take the 20 moles of CO2 and convert it into moles of lithium hydroxide, the other reactant. So I would get 40 moles of lithium hydroxide. So then I have to ask myself, do I have 40 moles of lithium hydroxide? In the question, you can see that I have 41.6, so yes. So if I have enough, then I know that my limiting reactant is going to be the carbon dioxide. So this is my LR. And this one's my ER. And just by chance, I might have decided to go the other direction. So let's do it that way too. So I could take my 41.6 moles of LiOH, convert that into moles of CO2. And when I do that, I get 20.8 moles of CO2. And if I ask myself, do I have this? I have to go back up here. Do I have 20.8? No, I only have 20. So I am going to run out of carbon dioxide. So my LR is CO2 and my excess reactant is LiOH. So let's do a couple more. So here we have another reaction. The arrow yield arrow didn't work very well. And in this case, both of the reactant amounts are in grams. So we would want to convert them to mole first. And I'm first just getting to moles of P4. So I have 0.202 moles of P4. And then my oxygen, remember it's going to be 32 because it's O2. Oops. So then I get 1.56 moles of O2. So now I have to determine the limiting reactant. So I'm going to take my moles of P4 and I'm going to convert that to moles of O2. So from my balanced equation, there's 1 mole of P4 for every 5 moles of O2. So 1.01 moles of O2 I would need in order to react with all of the 0.202 moles of P4. So then I ask myself, do I have this? Do I have 1.01 moles of O2? Yeah, I've got 1.56. So that means I have plenty of O2 and that my limiting reactant is the P4. So limiting reactant is the P4 and the excess reactant is the oxygen. So once I know which one is the limiting, then that's the one I'm going to use to determine this problem. So anything else other than determining the limiting, you're going to start with the limiting reactant. So the limiting reactant was the P4. So I'm going to start with gram again. If you wanted, you could start with your moles up above. Either way is fine. And then I'm going to do my mole-mole ratio. And there's 1 mole of the compound P4O10 for every 1 mole of P4. And then I'm going to use the molar mass, which I previously calculated. So you can see the main takeaway here is once you know which one is the LR, that's the one you always want to start with. And then that determines how much of this product I'm going to make. And then when I crunch it, I get 57.3 grams of P4O10. So one more type of question is if you are we're going to do the same thing here, but then at the end, we're going to figure out how much excess reactant we have. So let me show you. So first, we want to convert our reactants into mole. That's always our first step. And I had previously calculated the molar masses. So I have, to start with, I have 2.71 moles of ethanol and I have 121 grams of oxygen. And then remember the molar mass is 32. So I have 3.78 moles of oxygen. So that was my first step. My second step is I'm going to take one of these and convert it to moles of the other. I'll do that over here. So I'm going to take, it doesn't matter which one, I'm going to start with my ethanol. And I'm going to multiply by my mole ratio. So 3 moles of O2 for every 1 mole of ethanol. So when I do that, I get 8.13 moles of O2. So in order for 2.71 moles of ethanol to react, I would need 8.13 moles of O2. So then I ask myself, do I have it? Do I have 8.13 moles of O2? And my answer is no. So that means my LR is the O2. That's the one I'm going to run out of. So now that I know that's my LR, if I want to know how much product is formed in letter B, I'm going to start with my LR. And I could start with gram and then go to mole, but I'm going to start with mole this time just because I had already done it. And I'm switching over to carbon dioxide. So there's 2 moles of CO2 for every 3 moles of O2. And then the grams, the molar mass of carbon dioxide. So anytime after you know who the LR is, then you always start with the LR to determine, in this case, how much of the product is formed. So when I do this, I get 111 grams of CO2. So the next question now is new, where if I want to know how much of the excess reactant is actually going to remain, again, what I do is I start with my LR and I convert it into the moles of the ER. So I know that my ethanol is my excess reactant, and now I'm trying to figure out how much is really going to be left over. So by doing what I'm doing right now, I'm saying if I react 3.78 moles of O2, I'm going to use up 1.26 moles of ethanol. So that's how much will really react. Once I know that, then I take my excess reactant amount that I'm given in the question, and I subtract the excess reactant amount that will actually react. And then that'll tell me how much excess reactant there really is. So for me, in the question, we are given 2.71 moles of ethanol, and we know that 1.26 moles of ethanol are going to react. So then in that container, I'm going to have 1.46 moles of ethanol remaining or left over. So just to review, first thing I did in this problem is I convert my reactant amounts that are in grams to mole. Then I take one of the reactants moles and convert it to the other reactant moles. Then I ask myself, do I have enough of that? And if my answer is no, then that means that is my limiting reactant. If my answer was yes, then that means the reactant that I started with in the problem is my limiting reactant. Once I know the limiting reactant, then I start with that limiting reactant, and you can see I started with the limiting reactant here, and I got that here. So that is what's going to determine how much of the product I can make. It's also going to determine how much of the excess reactant will really react. So then in the question, we were given 2.71 moles of ethanol. And then we know that 1.26 we're going to react, so we subtract that. And you'll also notice when I determine the limiting, I never use that 8.13. That is just for me to determine whether I have enough of it. And if I don't, then I know then that is the one I'm going to run out of. That one's the excess reactant.